Hello Internet, welcome. This is going to be an episode about Python type hints. What are they? Well, you probably have seen some newer Python with this kind of syntax where you declare the variable's type as part of their declaration. This is super useful because we don't want to mix up and make errors and say something like string plus number, and we'd like to catch these errors at compile time, or well, before we actually run our code and see that things don't work as we think they should be. This, by the way, would error because we cannot concatenate strings to ints. We can only concatenate strings to strings, which is the correct way to do stuff. Looking at you, JavaScript. Now, this is like the basic kind of type hints, but we also have in Python crazier stuff because sometimes we have things like decorators, and they are quite crazy in terms of, well, they take some kind of function, and that function takes some argument or a lot of arguments and does some kind of manipulations to them. And we'd like to type that correctly. And this is usually non-trivial if you try to think about it, because we can modify the function's behavior in some sense. So in order to type that correctly, what we would want to do is some kind of, well, we need a function that accepts, well, another function and returns some other function. This is not a proper syntax. This is just so we'll have some kind of like sense of what we'd like to do. And this could be one function. Let's say this is a function that takes a function g and returns g prime, because we can modify the function's behavior in some sense. In order to do that, let's actually write our own decorator, which let's say does not modify the actual implementation, but let's say something like logged and have that here. And we would like to, well, run some kind of logging here. So let's pretend we have some logger, and we can now say logger info, and actually we can just go with info, and let's say we just log everything that passes through this function. So in this sense, what we would like to do is return the same function signature, but we'd like to know that that actually happened. So in this sense, we can start with something simpler, because we can just say we have a type variable t, and we can import that from typing, and we know that we accept type variable of type t and just return that same type. So this actually does a lot of brings us a lot of the way into typing this correctly, because we're not modifying the function signature, we're only returning a function with the same signature. But what happens if we actually want to modify what is actually happening here? But let's say that we have a function that accepts two parameters. Let's say we have some kind of context here, and this context is something that we pass around in some sense, and let's say something like context, and this is some complex object that we don't want to deal with all of the time, and we want to patch the context in regardless of where the function is called. So let's create our own decorator with context, and we'd like to inject a context variable right there. So already now we can see that this is not actually the correct type anymore, because we're getting a function that accepts the context but returning a function that does not accept the context variable itself. So a type hint here, the type variable here would not do any justice to our actual types. So let's actually modify our signature a little bit and import the new things to actually patch this up. So what we would want is something like, we need a function, and let's say that this is a type alias, just so our typing would be a little bit more concise. And this is just callable that accepts, I don't know yet, and returns some kind of type variable t. And what we want is to type the parameters themselves. So this is not a type variable, this is a param specification, and we'd want this kind of function. So we'd like function and the function, and here we accept t and t, and here we need to accept something and t. And this something here is our like magic stuff that we need to do, because we're actually, this is actually not even correct. This is the actual magic stuff, and this is here the param specification as we would have wanted to actually use it. So what happens here? We need to actually, if you can see, we are actually concatenating two things here. We're patching in the context variable and also the param specification of the function signature. So what we would want is to import, well, we would want to concatenate context. And actually, this is a tuple, or maybe not. Maybe this is just variable length. Yeah, okay. And concatenate the tuple with, concatenate context with our param specification. And this now means that we accept a function that receives both arguments, or one argument and more, and we return it patched with only that thing. And now we are supposed to be either fully typed, or maybe I've made a mistake. And we can actually, let's open up a console here, and we're with the correct, within the correct shell, and let's run mypy script on this, and let's see where the errors are. And we are on py typing, and this should be quite, function is missing type annotation. Nice. And yeah, we are missing p args and p keyword args. And now let's see if this is actually working. No untyped definitions. That is correct. No issues. So we've won. That's nice. Actually, as we can see, make with context return a callable with, let's see, param spec pt. This is actually, well, as you can see, my ID is actually incorrect. We're actually doing the right thing, and this is nice that we can actually see like the disagreement between mypy and the type checker of PyCharm, because this is like a testimony of how bad the typing ecosystem of Python is, right? In what bad shape like the Python typing ecosystem is right now. But as you can see, we have done like the thing that we sought out to do, which is to fully type our decorator with something that receives a function, and you can actually modify the arguments and return another function which has actually modified behavior. And we can also, by the way, patch, of course, the return type if we'd like. So what we could do is create like another decorator. Let's say, and this is a bad decorator. I would not recommend you to ever use this one, but you can, let's say, silence errors. What that would do, this would take a function and with the same type hints, which takes a param spec with p and t, and returns function which is a t or none. Or let's actually, you know what, let's be a little bit more nice, and let's say we have, let's say that we have like some kind of sentinel, which is a little bit more nicer than returning none. Let's say we have error sentinel, which is just an object, a singleton, and we have here a literal error sentinel. Is that possible? It can only be with literal values. So we'd like something even, can we just do that? We can just return the error sentinel itself. Okay, that looks like it might work. And errors, and our wrapper would now accept all the args as usual and return, well, we know the error sentinel itself. And yeah, this is actually the correct implementation, because as you can see, oh, this is incorrect. Let's see what, we're missing, of course, returning the actual wrapper. And we can now silence errors, and this would probably fully type check, hopefully. Let's go here, run mypy, and we have errors. Let's see what they are. They're saying this is not a type, and they are correct, because this is actually an instantiated value here. And maybe we'd like to do something. We can have that as type here. And then we can have this as like some kind of a little bit more, type more safely. And of course, we could have just returned the error itself. But in order to have like a fully typed result type, then we need to do a little bit more work, or maybe just switch to Rust if we'd like that kind of rigorousness. So in conclusion, what we've done today is we have fully typed our own decorators, where we can patch our parameters and have them still like fully type safe. And by the way, we can actually see that this will error out now if we go to our shell and remove the context and type check this, and it will probably say, yeah, with context has incompatible type callable stir, and it expected a callable of context stir, which is really nice that we can say that now, that we can see that this actually fails to type check if we forget to actually consume this context object that we have created. And this is quite nice that we can have that kind of like level of safety with MyPy. Just by using regular type hints with some special type hints there, which are the param spec, and actually not that param spec, concatenate, and not a lot of magic. And like this is probably something that you could read and understand what's going on here. So I hope you enjoyed it. I hope you learned something new. And I'll see you next time. Bye.